All right, so why don't we go ahead and do some t-tests here in R. So in order to do that, I first need a data set. As you all know, I love the IRIS data set. So IRIS data sets contains, if you run it, which I did, there we go. Okay, so this is the IRIS data. It has 4 different measurements. We've got sepal length and sepal width, petal width, petal length, and the species. So the first thing I want to do is I want to see what the true sepal length is. So I'm going to calculate the mean of iris sepal length. And this isn't going to be like the best version of a t-test, right? So if I calculate the mean, I get a mean of 5.8. So when I do a t-test, I can have it be a left-tailed, right-tailed, or two-tailed t-test. So let's take a look at the t-test code. So I'm going to type in a question mark dot t-test, right? So I can have it be two-sided, which is my null hypothesis is doesn't equal, less than, which would be left-tailed, and greater, which would be right-tailed. So let's say I want to, what do I want to do? Okay, so let's say I want to test that my null hypothesis is that, and we'll use pound to type this out. So my null hypothesis is that the true mean length of sepals of irises is 6. And my alternate hypothesis, my H sub A, is that the true mean does not equal 6. So this would be a two-tailed t-test, right? So I can set this up. I'm going to do a t-test. My data set is iris sepal length. My mean is that it's 6, and I'm going to say that this is two-sided. So alternative C, 2 dot sided. Make sure you actually spell it right. It's right here, 2 dot sided. I'm always tempted to do a dash. I needed a comma. All right, so I got a p-value of 0.02. So alternative hypothesis was that the true mean is not equal to 6. So there is enough data for us to reject our null hypothesis because we have a really low p-value. We want a p-value of less than 0.05. So in this case, we could reject the null hypothesis. And remember, there's only rejection, no exceptions when it comes to alternative hypothesis. Now, this might not be the best way to analyze this data because when I'm looking at this sepal length data, I've got these 3 different types of irises together. I have Virginica, Versicolor, and Setosa. You think I'd have this memorized by now, right? So what I want to do is I want to do a 2-sample t-test. And for a 2-sample t-test, our null hypothesis is that the means are the same. So this is kind of like an ANOVA, but not quite. Means are the same. And then my alternate hypothesis, H sub A, is that my means are different. So what I want to do first is I want to break my data set into subsets by iris species. So I'm going to have one called Setosa, SL, which as you can see, I've already defined, but that's okay. That's going to be my iris data set. I go in and I take the iris species. And when this equals, double equals setosa, I want it to give me sepal length. And I just care about sepal length. I don't need anything else. So what I'm doing is I'm creating a new data set, setosa sepal length. It goes into the iris data set. It goes to when iris equals species. And when it's setosa, another quotation mark here, it's going to give me and return only the sepal length. Let's make sure that this runs. Unexpected symbol. Ah, there's 2 right there. There we go. Victory. Okay, so then I could calculate the mean of setosa SL, which is just the sepal length. Look, and it gives me the mean, right? So I'm going to test that all these means are different. So I'm going to copy this code and paste it twice because I'm going to do the same thing for Virginica. And I'm going to do the same thing for versicolor. We'll call that versicolor. Okay. But it would help if you spelled it correctly, versicolor, so that I can run this code. There we are. So if I wanted to look at this data set and do a t-test, so my sample size needs to be bigger than 30, and I'm going to have a sample size of 50 each because there are 50 of each species. But I also need to make sure this data fits a normal curve, right? Or looks normal-ish. So I'm going to do a histogram of setosa. Why did it do that? I'm going to do a histogram of setosa SL. All right, that looks pretty normal to me. I have to check my other 3 data subsets as well. Virginica, that also is pretty darn normal. And last, let's make a histogram of versicolor. All right, and that's pretty normal as well. And I'm going to do a 2 sample t-test, but I don't know which 2 I want to test. I can't do 3. We'd need an ANOVA for that, which we will do later. But let's make a box plot so I can look at these all at the same time. So I'm going to do a box plot of versicolor, Virginica, and setosa. And I probably could have done that alphabetically, but I did not. Okay, so here are my 3 different box plots. We can see from visualizing these that setosa is like really different. That's our 3rd one. This is 1, 2, 3. They go in the order I listed them. Setosa is really, really different. So maybe I want to do a t-test that there's no difference in Virginica and versicolor. It's something about those V named species. I don't know. So for this, I'm going to do a t-test. I'm going to do setosa SL, not setosa, sorry. I said I don't want to do setosa. We're going to do Virginica and versicolor. I'm going to say the true mean difference is 0. So there's no difference in our means. This mu in this case, let me label that. Mu means mu is difference of means in a true way t t-test. So my means is 0. I'm saying there's no difference in the means. Those are practically the same. And I'm going to have to pair this data because my data sets are the same size. We're going to type in paired equals true. We're matching each piece of data. Data sets should be about the same size. You can do paired equals false if your data sets are not the same size, or just leave it out, and your code will work as well. So let's go ahead and run this t-test. So as we can see, we got a high significance value, right? That means we reject a very low p-value, which means we reject our null hypothesis. The two means are not equal, right? And we don't accept, but we fail to reject our alternate hypothesis. So in this case, we would reject our null hypothesis at the 0.01 confidence level. Remember, we want it to be at least 0.05, but we never reject a null hypothesis at anything lower than the 0.01 confidence interval. So a good thing to include in your research might be a box plot, well labeled, like label everything more nicely than I did, give it a title, make it a pretty color, because that's some visual evidence of your t-test, right? Okay, visually we could see that there is a difference, and when we did a t-test, it proved that that was significant. So stay tuned. Next video will be over ANOVA, analysis of variance, and we'll be working with these same three data sets we created.